Okay, we've got quite a nice vector geometry problem. This one courtesy of Save My Exams. Um, so when we've got unknown ratios in lines, as you'll see with this one, it's always an added bit of complexity. Uh, I think this question's a little bit unfair, and I'll explain why as we go through. Okay, so let's have a look. Figure 7 shows a sketch of a triangle OAB. C is such that OC equals 2OA, so we've drawn that over here. So this extends OA up to C here, and these two parts, OA and AC, are both A. M is the midpoint of AB. Here we go. Uh, M there. And the straight line through C and M cuts OB at the point N. We only need that per um, second part. So we're given that OA equals A and OB equals B. That's what we've got there. Find CM in terms of A and B. Okay, well, this bit's fairly straightforward, really. CM, okay, well, we basically want to get from C to M is our sort of our mission. And we don't know this vector. That's what we're trying to find out. But if we take a kind of an alternative route, we will get the same vector. So if we go via A, CA plus AM, then we've got a fighting chance. So CM equals CA plus AM, which is the start. CA, well, A, what is AM? AM is half of AB. Right, okay, well, we've got a chance of getting AB. So half of AB, and in fact, AB is going to be, again, if we go from A to B, we can go via O, AO plus OB. Right, so CA equals half AO plus OB. Well, we know CA because it's minus A. AO is minus A as well, and OB is B, of course. So if we write that, we substitute in the algebraic values, and then we just rearrange and simplify. We're going to get this, which is what we're asked to find: minus 3 over 2A plus half B. Right. Okay. So let's have a look at the second part here. Right, so I've redrawn the diagram here. Show that ON equals this expression here, an A part and a B part, where lambda is a scalar constant. Okay, so, well, what do we say? Well, we want to find out. We want to get from O to N, don't we? So here's a route which I think has got a fighting chance. It's going to go OA. AM, and then MN. Now, the only problem with that is we don't know what MN is. We do know what CM is, and of course with that we've got so we know it's a scalar multiple, don't we, of CM, because it's collinear. So if we introduce a scalar parameter here, then that will at least allow us to progress. So I have said, and this is where the catch comes in, let Mn equals mu Cm. Okay, so they're in proportion. Sorry, well, I've said that it's Cm to Mn equals 1 to mu. So it's sort of the assumption I've made, and that therefore gives us that Mn is mu Cm, where we know Cm, we've just calculated it in part A. Right, so let's work that through, and with any luck, our mu will be our lambda here, and all will be well. So On is therefore, if we're taking the route from O to N, we're going to go via A and via M. So we're going to go OA AM plus MN, which we've just said is equal to mu CM. Now AM is going to be half of AB, as we've uh, seen before. So that's half of AO plus OB, which is half of minus A plus B. Right, so we've got that bit now. we calculated that before. So if we put all those bits together, ON equals A, that's from the OA, plus this, which is RAM here, and then mu times RCM, which we calculated in part one. Right, okay, so ON is equal to this. Now, if we rearrange this, so we got all the A components together there, and the B components there, and we compare it to this, it's not the same. Right, okay. So you're in an exam, you get there, what do you do? Okay, fortunately, I gave myself a little bit of time to kind of look at this, and essentially by substitution, actually probably not really that difficult once you see it. But if we let lambda equals 1 plus mu, so mu equals 1, lambda minus 1, and we therefore rework this expression here, then what we actually get, I just need a little bit more space here. What we actually get is that ON is therefore equal to, there's my lambda minus 1 in there. That 1 plus mu here is going to be lambda here. So we get this expression, which when we simplify is this, which is what we've been asked to find. Now, I think if you're in an exam and you're doing that, actually seeing that trick might not be that straightforward. And I think the point here I'm getting to is we could have chosen anything. We chose Cm to Mn is 1 to mu, so Cm to Cn is 1 to 1 plus mu. But we could have taken Cm to Cn equals 1 to whatever. If we chose lambda, it would have worked out perfectly first time. Probably would never even have realized that it was potentially difficult. We would have stumbled across the right ratio to take. But equally, we could have taken Cm to Cn is lambda to 1, or even we could have looked at this ratio here. So we can if we make an assumption about this ratio here, we should haven't worked it through, but I'm pretty sure we could actually work that through. Now, so really, you're finding this correct solution on this is pretty well dependent on stumbling across that. And it's I don't think there's any way you could say it's obvious that that is the ratio that you would take. So, so yeah, a little bit unfair, I would suggest. Anyway, you may not get this. This is on Save My Exams, but it won't necessarily be an exam question, but something just to be aware of. Now, there is a little bit more on this one because there is a part C, which says, hence prove that ON to NB is 2 to 1. Right, now this is an interesting theme that actually may well come up. Now the point is that ON and OB are collinear, and we talk about parallel because that means that one is a scalar multiple of the other. Now we're looking at this expression here, so this can only mean that the A component of this must be 0. And if for it to be 0, this must be 0, which means, following this calculation through, that lambda has got to be 4 over 3. All right, so if lambda is 4 over 3, then ON is going to be a half, that half, times 4 over 3 for lambda, B. Or in other words, 2/3 B, which means that ON to OB is 2 to 3. Yeah, this is 2/3 the way along there. And therefore, ON to NB is 2 to 1, which is what we're asked for. Okay, so that is it. The moral of the story? Well, yeah, if we've got unknown ratios, You may well have worked out the right answer, but just chosen the wrong wrong ratio. Um, but in that case, perhaps some kind of uh, mapping, between those would actually solve it for you. So I suggest when you do this that you don't use lambda, that you use mu, because when you actually come to do this sort of conversion here, then it just makes it a little bit more straightforward. Um, and then also watch out for this business when, if lines are collinear or parallel, essentially, then the if we're using A and B, we often are, um, then these must be in proportion to each other. And in this case, of course, that means that this one is zero. Okay, so hopefully that's been useful, and thanks for listening.